So hello everyone. In today's class we'll see how to apply superposition theorem for AC circuits. So this is the first question. You are asked to find the current flowing through J2 ohm. So by superposition theorem we'll consider only one source at a time and we'll set all the other sources equal to 0. So in this case we'll first consider this 5 angle 0 degree voltage source acting alone, and we will set this 2 angle 0 degree ampere current source equal to 0. So the figure will be like this. So we have open circuited the current source. Now we have to find the current flowing through J2 ohm. I have marked that current as I dash. So I dash will be equal to 5 angle 0 divided by 4 minus J2. There is no current flowing through this J5 ohm since it is open. So we'll get I dash. Next thing is we have to consider the second source and set the first source, that is the voltage source, equal to 0. So we have set the voltage source that was here. We have set that equal to 0. We have short circuited it. Now we have to calculate the current flowing through J2 ohm. So I have marked that current as I double dash, and I double dash will be equal to total current into, we can apply current division formula here. So I double dash will be equal to the total current to angle 0 into the impedance of the other branch, that is 4, divided by the total impedance, that is 4 minus J2. So by superposition theorem, so we have got the two currents I dash and I double dash due to each source acting separately. And now we'll sum up those two, we'll get the current flowing through J2 ohm. So I will be equal to I dash plus I double dash. So you have to find this value of current. You have to find I dash, you have to find I double dash, and then sum up the responses. So in the previous video of solving AC circuits using Thevenin's theorem, Professor Mansoor has explained how to solve using calculator, how to solve this type of circuits using calculator, that is rectangular to polar, rectangular and polar things. How can you divide and all? So go through it if you have not seen that video and do the calculation part. Okay, now we'll move on to the next question. So you are asked to find the current flowing through this 8 ohm resistance. So first we'll consider there are two sources in the circuit. So first we'll consider this 10 angle 30 degree voltage source acting alone. So we'll open circuit this current source. So it is open circuited over here. So I have marked the current flowing through 8 ohm as I dash. So our aim is to find I dash. So I dash, in order to find I dash, I have to find the total current flowing through the circuit I. So in order to find I have to calculate the equivalent impedance. So the equivalent impedance in this case is 8 and minus J2 are in series. So 8 minus J2, that is in parallel with J4. So 8 minus J2 parallel J4, and that whole thing will be in series with 6 ohms. So plus 6. So you will get the equivalent impedance. So find the equivalent impedance, then find the total current I. That will be equal to the voltage 10 angle 30 divided by Z equivalent. So find the current I. Next is the current I dash. So that is the current flowing through 8 ohm. That will be equal to the total current I into total current I, that is this thing, that into the impedance of the other branch, that is J4, divided by total impedance, that will be equal to 8 minus J2 plus J4. So you'll get I dash. Next you have to calculate the current flowing through 8 ohm with 2 angle 0 degree ampere current source acting alone. So we will set the voltage source equal to 0. So we have set this voltage source 10 angle 30 equal to 0 in this case, and we are considering only this 2 angle 0 degree ampere current source. So I have marked the current that is flowing through 8 ohm as I double dash. So our aim is to find I double dash. So in order to find I double dash, we can redraw the circuit for the ease of simplification. That is, this point is B and also this point is B. This point both are the same. That means this J4 and this 6 ohm are in parallel. So we can redraw the circuit like this, and also this current source is coming across A and B. So the whole circuit is redrawn like this. Now it's easy to simplify. So we have to find the current flowing through this 8 ohm. So what I have done is I have taken the equivalent impedance of these two parallel branches. So that will be equal to 6 parallel J4, that is denoted as Z1. So I have found Z1. Now I can draw the circuit like this. It is Z1 instead of J4 and 6 ohm in parallel. It is Z1. Now I double dash will be equal to, applying current division formula, total current 2 angle 0 into impedance of the other branch, that is Z1, divided by total impedance will be equal to Z1 plus 8 minus J2. So you'll get I double dash. So the current flowing through 8 ohm is in the same direction in both the cases. So we can sum up those two. We'll get the total current I flowing through 8 ohm. So that is the second question. Now we'll move on to the third question. You are asked to find the current flowing through this J6 ohm. So there are two current sources over here. One is 2 angle 30 degree and another one is 4 angle 60 degree. So first we'll consider only one source at a time. That is, we are going to consider only the 2 angle 30 degree current source. So we'll set this source equal to 0. So that is not active over here. It is set equal to 0. Now we'll find the current flowing through J6 ohm. So the current flowing through J6 ohm will be I dash. So I dash will be equal to, we can apply the current division formula over here. So total current 2 angle 30 into impedance of the other branch, that is this branch. So 2 plus J4 divided by total impedance, that is 2 plus J4 plus 3 minus J6. So you'll get I dash. Next is, we'll consider the second source acting alone, that is 4 angle 60 degree acting alone, and we'll set this equal to 0. So a figure is like this. So we have to calculate the current flowing through this J6 ohm. So again we can apply current division formula over here. So I double dash will be equal to total current 4 angle 60 into impedance of the other branch is this branch which consists of 3 ohm, 2 ohm and J4 ohm. So 5 plus J4 divided by total impedance is 5 plus J4 minus J6. So current is flowing in the same direction in both the cases. So we can sum up those two to get the current through 6 ohm. So I will be equal to I dash plus I double dash. Next question, obtain the current in 3 plus J4 ohm. You do it by yourself. So there are two sources over here, two voltage sources. So first consider only one source at a time. So 50 angle 90 degree acting alone. You will set this equal to 0. Find the current flowing through this particular branch. Next, you have to consider 50 angle 0 degree acting alone. So we will set this equal to 0. Find the current flowing through this particular branch and add up those two. You will get the current in the 3 plus J4 ohm resistor. Now moving on to the next question. You are asked to find the voltage across 2 plus J5 ohm. So what you have to do is first find the current flowing through 2 plus J5 ohm, and then we can calculate the voltage as V is equal to I into Z. So first we'll consider only one source at a time. We are going to take only the voltage source now. So we are taking the 50 angle 0 degree voltage source. So we have set this current source equal to 0. So a figure will be like this. So we have to calculate the current flowing through this particular branch. So that is denoted as I dash. I dash will be equal to 50 angle 0 divided by J4 plus 2 plus J5. There is no current flowing through this capacitance since it is open. So V dash will be equal to I dash into Z. Z is 2 plus J5. So now next we will consider the 20 angle 30 degree ampere current source acting alone. So we'll set this 50 angle 0 degree voltage source to 0. So it is set to 0, short circuited. Now we'll find the current flowing through this particular branch, 2 plus J5 ohm, and I have denoted it as I double dash. So I double dash will be equal to the total current, that is 20 angle 30 degree, into the impedance of the other branch, that is J4, divided by total impedance is 2 plus J5 plus J4. So you will get I double dash. Next is, you have to calculate V double dash, that will be equal to I double dash into Z, that is 2 plus J5. So you will get V double dash. So we have to calculate the voltage across 2 plus J5 ohm. So the voltage drop due to both sources will be V is equal to V dash plus V double dash. Sum up the voltages, will get the voltage drop across 2 plus J5 ohm. So that is the fifth question. Now we'll move on to the next question. We are asked to find the current flowing through this 4 ohm resistor. So first we'll consider this particular source, current source acting alone. We'll set this voltage source equal to 0. So our figure will be like this. And the current flowing will be equal to I dash with 20 angle 0 degree ampere current source acting alone. So we can find I dash. So in order to find I dash, I'm going to take the equivalent of this particular impedance and this particular impedance. This is Z1 and this is Z2. So Z1 is 5 and J2 ohm in parallel. So 5 into J2 divided by 5 plus J2. And Z2 is 2 and minus J2 in parallel. So 2 into minus J2 divided by 2 minus J2. So you will get Z1 and Z2. So you can redraw the circuit like this. 20 angle 0. Here it is Z1. Here it is 4 ohm. Here it is Z2. Now we can calculate the current flowing through 4 ohm, that is I dash, that will be equal to total current 20 angle 0 into impedance of the other branches Z1 divided by total impedances Z1 plus 4 plus Z2. So we'll get I dash. Now next is we have to consider the second source acting alone. That is we are going to consider the voltage source 100 angle 90 degree voltage source acting alone. So we'll set this current source equal to 0, means we'll open circuit this. So our figure will be like this. So 5 and J2, I have taken the equivalent of that. It is Z1. So it will be like this. Z1 4 ohm minus J2 to 100 angle 90. So we have to calculate the current flowing through this particular resistance. So that will be I double dash. So I double dash will be equal to, we can find I double dash by mesh analysis or circuit reduction. So I'm going to find I double dash by circuit reduction. So I double dash will be equal to Z1 plus 4, that is in parallel with minus J2. So Z1 plus 4 parallel minus J2, and that is in turn in series with 2 ohm, so plus 2. So Z1 plus 4, that is in parallel with minus J2. Z1 plus 4 is parallel with minus J2, and that is in turn in series with 2 ohm. So we can find the equivalent impedance, Z equivalent. So Z1 plus 4 into minus J2 divided by Z1 plus 4 minus J2 plus 2. So in order to find the total current will be equal to, the voltage is 100 angle 90. So 100 angle 90 divided by Z equivalent gives the total current flowing through the circuit. Now we have to calculate I double dash, which is the current flowing through this particular resistance. So that will be equal to total current into impedance of the other branch, that is minus J2 is the other branch, divided by total impedances Z1 plus 4 minus J2. So we can will get what is I double dash. So the current through 4 ohm I will be equal to I dash minus I double dash, because here in the first case the current is flowing from left to right. When we are considering the 20 angle 0 degree current source acting alone, current is flowing from left to right. And when we consider the voltage source acting alone, we can see that the current is flowing in the opposite direction, that is it is moving in this direction from right to left. So the current flowing through 4 ohm is opposite in two cases. So we'll subtract the two currents. So net current flowing through 4 ohm will be equal to I dash minus I double dash. So now the next question is, you are asked to calculate the current flowing through 2 plus J3 ohm using superposition theorem. So for this example, I am going to reduce the circuit using mesh analysis. So first what we have to do is, we have to consider only one source at a time. That is, I'm going to consider only this 30 volt source at a time. So I'm short circuiting the 20 volt source. So figure will be like this. So considering 30 volt source acting alone, so I'm going to write the mesh equation. So I'm going to write the matrix by inspection. So it is 5 plus J5, R11 is 5 plus J5, the sum of the resistance in loop 1, that is 5 plus J5. Next is the resistance which is common to loop 1 and 2, that is minus J5. Next is the resistance which is common to loop 1 and 3, that is 0. Similarly, we have written the for the second loop also and third loop also, into I1 dash, I2 dash, I3 dash will be equal to, there is only one voltage source in this case, so 30 volt. So it is the current is in the clockwise direction. So there is a rise in potential when we encounter this 30 volts source. So it is plus. So 30, here there is no source, so it is 0. Here there is no voltage source, so it is 0. So we have got the matrix like this. Now our aim is to find current I2 dash. So I2 dash will be equal to the current I dash itself. So the current I dash will be equal to I2 dash. So we have to find I2 dash. So I2 dash, in order to find I2 dash, we can use Cramer's rule. So that is delta 2 by delta. So delta 2 is, we are replacing the second column of this matrix with the right hand side matrix, that is Ax is equal to B. This is in the form Ax is equal to B. So we are replacing the second column with the B matrix. So we'll get delta 2. So I have replaced the second column with 30 0 0 divided by, that is delta 2, the determinant of that divided by the determinant of the A matrix will give the value of I2 dash. So calculate I2 dash. So our I dash will be equal to I2 dash. It is not I2 double dash, it is I2 dash. Next, we'll consider the 20 volt source acting alone. So we'll set the first voltage source equal to 0. Now we have taken the currents in the clockwise direction. We'll write the equations by matrix by inspection. So here this A matrix will be the same as in the previous case, into I1 double dash, I2 double dash, I3 double dash. I have marked the currents as I1 double dash, I2 double dash, I3 double dash. That will be equal to, there is no voltage source over here in the first loop, so it is 0. No voltage source here, it is 0. And in the next case, the current is in the clockwise direction. So here there is a drop in potential, so the voltage is minus 20. So now our aim is to find I double dash, which is equal to I2 double dash. So we have to find I2 double dash. So I2 double dash will be equal to delta 2 divided by delta. So we are replacing the second column with this matrix. So we'll get delta 2 divided by delta. So we have to take the determinants. We'll get I2 double dash. So current through 2 plus J3 ohm will be equal to I dash plus I double dash. Next is, we have to find the current in 4 ohm resistor due to each of the voltage sources. So we have to consider each of the voltage. It is not asked to find the current flowing through 4 ohm resistor. In the question, it is asked only to find the current in the 4 ohm resistor due to each of the voltage source. So we don't have to add up the response. We have to just find the current in the 4 ohm resistor due to 50 angle 0 degree voltage source, and the current in the 4 ohm resistor due to 50 angle 90 degree voltage source. So first we'll consider the first voltage source. So we'll set the second voltage source equal to 0. So we'll short circuit it. Now I have taken the mesh analysis method here also. So I have marked the currents as I1 dash, I2 dash, I3 dash, and the current flowing through, our aim is to find the current in 4 ohm. So that is equal to I dash. So I dash is equal to I2 dash itself. So we have to find the current flowing through 4 ohm, that is I2 dash. So here we can write the matrix. So Z11 will be equal to the sum of impedance in loop 1. So it is 5 plus J2. Z12 was the impedance common to loop 1 and 2. So that is minus J2. And Z13 is the impedance common to loop 1 and 3. So it is 0. And for the second loop, here Z21 will be equal to minus J2, impedance which is common to loop 2 and 1. And sum of the impedance of loop 2 will be equal to 4 plus J2 minus J2, that is equal to 4. And impedance common to loop 2 and 3 will be equal to J2. It is minus J2, so it is minus of minus, so it is J2. Similarly, for the third loop also, into I1 dash, I2 dash, I3 dash will be equal to, so here it is plus over here and minus over here. So it is plus 50 angle 0. Here there is no voltage source 0. Here also there is no voltage source, so 0. So we have to calculate I dash, which is equal to I2 dash. So I2 dash will be equal to delta 2 divided by delta. You have seen in the previous problem how to find delta 2. Next, we have to consider the 50 angle 90 degree voltage source acting alone. So we have set the first voltage source equal to 0. Now we are writing the matrix again by inspection, and here this matrix will be the same, and here this B matrix will be equal to, there is no voltage source over here, so it is 0. Here there is no voltage source, so it is 0, and here there is a voltage source, it is 50 angle 90 degree. So the direction was given like this. Here current is flowing in the upward direction, so it is plus here and it is minus here, so it is minus 50 angle 90. So we have to calculate I2 double dash, which is equal to I double dash. That's all. So you are not asked to find the current flowing through 4 ohm. You are asked only to find the current flowing through 4 ohm due to each of the voltage sources. So find that only. So I have explained all the 8 questions. Now it's your duty to solve all these 8 questions and submit. Okay. So I'll tell the date when to submit this. Thank you.